All right, let's take a look at this problem. Here we've got an equation. C2H2 is going to decompose to 2 carbons and hydrogen gas. We want to know our delta H, and we're going to use these 3 equations and these delta H values to come up with what it would be for this reaction. So for this, I'm just going to try to look to this equation to find out or see if I can identify the substances in my equation in these 3 equations. So C2H2, I find that right here, so we can give a little circle here. 2 carbons, well, we've got 1 carbon here. And then hydrogen, H2, we've got H2 right here. If we look at this first equation, the C2H2 plus 5 halves oxygen gives us 2 carbon dioxides plus water. It's all set up, right? We've got the C2H2 as a reactant. We do in our equation that we're interested in. We have 1 in each of them, so we're going to set this equation up just the way it's set up on here. And we don't have to do anything to our delta H. It's going to stay negative 1299.5 kilojoules. For this second equation, I've got twice as much carbon up top, and it's on the other side, so I'm going to have to flip this and double it. So I'm going to have 2 carbon dioxides as a gas decomposing to 2 carbons and oxygen. Again, I'm doubling it, so I forgot to put the 2 out in front of the oxygen. And since I flipped the direction and doubled it, I'm going to have to take my delta H as 393.5 times negative 2. I doubled it, and then that negative takes care of the switching the direction of the reaction. And in our bottom reaction, all I have to do is switch it. So I've got H2O as a liquid decomposing into hydrogen gas and 1/2 oxygens, also a gas. And my delta H, all I have to do is multiply this one by -1 because I flipped it, times -1. Ran out of room there. Now notice, let's just do a confirmation that everything is going to cancel out except for the parts that we're looking for. On the left side of my arrows, I've got 5 halves oxygen, which would just be 2.5 oxygens. On this side, I've got 2 oxygens and 1/2 of an oxygen, so we can get rid of our oxygens. So our oxygens are going to go away. I have carbon dioxides, 2 on this side, and I've got 2 on the other side. And I've got a water on this side, and I've got a water on this side. So if I look at all the things that I've got left, I have C2H2 forming 2 carbons and H2. And now all I have to do is add together all of my delta H's. And if I do that, I should end up with negative 226.7 kilojoules. And that's how you do that problem.